Hello everyone, in this video I will be demonstrating a new framework called TextLens. I developed this framework personally and I have been posted this on GitHub. You can just go to this link and clone this and use it. Before getting into this framework and explanation, I want to show you the agenda of today's video. So this is the agenda of today's video. In today's video, we'll be seeing about OCR and VLM based OCR. You need to understand the difference between OCR and VLM based OCR, and we'll be seeing GPU and CUDA. And yeah, I'll be showing a video from Nesso Academy to understand the SIMD, single instruction and multiple data, and parallel processing. Why? Because once you understand all these terminologies, you will be understanding the importance of TextLens framework. Then why VLM needs a GPU? There is a bottleneck between CPU and GPU when it comes to running a large language model or vision language model. So once you got to understand what is GPU and CUDA and SAMD, you'll be understanding the need of GPU for the vision language model. Then, introduction to the text lens. Here's the actual content begins, and the explanation and demonstration will be covered in this phase. Then I'll be running few sample code snippets for explaining the usage of text lens. Either it can be in my IDE like a VS Code, or it can be in my CLI or my terminal. Okay, now let's start with the OCR and VLM based OCR. First of all, you need to understand what OCR is. OCR stands for Optical Character Recognition, which means extraction of text from documents or image, whatever it can be. So OCR task is just to extract the image. OCR doesn't have intelligence. You need to understand it. Say, let's take this example. It is an invoice, right? It has an invoice number, date, and whom this invoice to. We have a tabular format. We have the columns and rows. This is the invoice. So it is considered as an input document. It can be either a PDF or it can be image. In pre-processing, we'll be talking more about this PDF and images. And in pre-processing, so we're talking about the OCR, right? This is a raw OCR, not VLM-based OCR. In this pre-processing, the text is enhanced. As you can see, this image is not bold, and after the pre-processing, the images become somewhat bolder. Why? Because for understanding and extracting the characters from this invoice, we need to enhance this text to make the OCR engine better. After this, we'll be seeing text detection. This text detection, you can see each and every field is being marked around by a bounding box. This invoice is detected. This is called region detection. Each and every region is detected and been marked with the bounding boxes. After that, text recognition will happen. There are a lot of OCR models are available there. It can be, wait, I will show you some. So this is the OCR model. Yeah, these are some OCR models. It can be Tesseract OCR, Paddle OCR, EC OCR, DocTR OCR. There are plenty of OCRs are available out there. Now we'll be seeing something called CUDA. CUDA stands for Compute Unified Device Architecture. So CUDA is a sole proprietary of NVIDIA. So CUDA is a kind of software platform which is being created by NVIDIA to program their NVIDIA graphics card or GPUs. GPUs are very well known for massive parallel computation. Like if you need to process a data parallel application, or say if you need to multiply a huge dimensional matrix, GPUs are highly capable of doing those tasks. So originally, you see, originally GPUs were designed for graphics. In the olden days, we call something like a video card, right? If you need to render and if you need to display the pixels in the monitor, you need to do a lot of graphical processing. For rendering the graphics, that the processing may involve rasterization, shading. All these processes been handled by the video cards those days. And now GPUs have a huge amount of parallel computing capabilities. So now we are having something called GGPU, General GPGPU, which is called a General Purpose GPU, which is used for tensor processing, matrix multiplication, kind of, calculating convolutions and vector operations. Say you have two matrices, A and B. Now, A and B have enormous matrix. It can be say 10,000 cross 10,000 matrix. A CPU can perform some kind of parallel operations, but not like a GPU. Why? Because CPU performs sequential operation. See, if you take instruction, say you have operation 1. After this operation 1 complete executing, then only the operation 2 can execute. So it's a sequential operation. So that's the bottleneck of CPU. It can't able to execute multiple instructions at a time. So one operation at a time. So that's the bottleneck of the CPU. When it comes to GPU, it has more number of ALUs. I mean, it has a lot of ALU. If you see the architecture of CPU versus GPU architecture, you can clearly see the difference. Let's see this image. Exactly. If you see, this is the architecture of the CPU and this is the architecture of the GPU. You can see the CPU has very minimum number of ALUs and it has a big control unit. Whereas in the GPU, you can see it has multiple ALUs and a small size of control unit. Why? Because its primary task is to give you a high throughput, whereas this CPU is intended to give you low latency. So you need to understand the difference between the CPU and GPU. So GPU is having a lot of ALUs so that it can perform parallel computing. However, TextLens helps the users and developers to easily integrate the OCR system into their applications. And before getting into it, we need to see, like we have seen the CUDA and all the GPU kind of things, right? Architectures and Flyn's taxonomy. In order to execute instruction in your GPU, you first need to ensure that your system supports the NVIDIA hardware. So for that, open a task manager. Right click and get the task manager and go into the performance. You'll be getting this page. So currently my system is having the Intel i5 13th generation CPU and I'm having a 16 GB of RAM and I have a 512 GB of NVMe SSD. And see, I have an NVIDIA GeForce RTX 4050. So it is a 6 GB VRAM dedicated GPU. And I have another GPU which is integrated graphics which has been come along with the Intel chip. You have a GPU like NVIDIA GPU. Just go to Chrome and search NVIDIA toolkit download. You'll be going to this first link. This is the toolkit which you must need to install in order to use the GPU accelerated environments. So choose your operating system minus Windows. If you have Linux, you can choose it. And x64 architecture and my Windows 11. Just click the exe local. You'll be getting a download link. You will be getting a exe download. Like you'll be downloaded with the executable file. Then open and install it. And ensure you have enough disk space to install this CUDA toolkit. Once installed, you need to you need to first wait. You need to check for proper hardware. Then you need to ensure you have NVIDIA toolkit, NVIDIA CUDA toolkit. Then you need to ensure adding it to your system path. Now you have done all this. Now you need to verify whether the CUDA is installed properly in your device or not. What will you do? Just open your terminal. It can be either a command prompt or a PowerShell. Enter this command NVIDIA slash hyphen SMI. You'll be getting this kind of a box like thing. Here you can see the installed CUDA driver version. Like the CUDA version is 13.1 and the driver version is 592.82. And currently you can see the utilization of my GPU. So this is 6141 MB. I mean the 6 gigabytes of VRAM. 605 MB is being utilized right now by this task. You can see which process is using the GPU. And this is the this is the watt that's consumed by the GPU. If you throttle your GPU, this watt will keep on increasing. My GPU is 75 watt supported. If you have a good GPU, like if you have a 145 TDP GPU, it will show you 145 TDP. That's based on your hardware. Then another important thing, you need to check whether you have CUDA compiler installed or not. So just type NVCC version. You'll be seeing this output. I have installed the CUDA compiler driver, which is CUDA 12.6 version. Like if you enter this command, you need to get these two outputs, or else you have done some mistake in your installation. So ensure that you are getting this. After this, we are going to install our TextLens package. And right now, you see, you need to do all these things to ensure that you have a GPU support. Now, if you want to use a GPU powered application or a framework, say if you need PyTorch, PyTorch is actually available in both CPU as well as in GPU, but I prefer using PyTorch in a GPU version. So just to go to the PyTorch once again, um, get started. Yeah, exactly. So in the PyTorch, you can see this PyTorch is for this is compute platform. Currently, you need to have a CUDA supported drivers. Like currently, we have CUDA. As you can see in my terminal, we have CUDA drivers and CUDA compiler installed. So I'll be selecting this. And so till now, we have seen what is CUDA and why CUDA is needed for GPU. We have seen a clear differentiation between CPU and GPU, and we have seen the bottlenecks of CPU also. Now we will be seeing something called SIMD, which is called single instruction multiple data. So let me show you a video. The video like I want you to show is from Neso Academy. So let's just watch this video. SIMD stands for single instruction stream multiple data stream. So what does it mean? It means from the memory, only a single instruction will be fetched by the control unit, that is single instruction stream, and based on that single instruction, the control unit will tell separate operate sections, that is separate ALUs, to bring their own specified data from the memory, operate on them, and then produce the results. This architecture is majorly followed in GPUs or the graphics processing units or graphics cards. Let me tell you how using a small example. Let's say we are going to increase the brightness of an image. Now, any digital image is the accumulation of multiple pixels, and in each pixel there is a color set called RGB triplet. So when we are increasing the brightness of the entire image, we are basically altering the RGB values of every pixel. That is, single instruction, increase the brightness, being operated on multiple data set, that is every pixel of the image. And that's what SIMD is all about. This is the image, right? So in this image, you can see image has multiple pixels, and each pixel, like in the image, usually it will be like around 0 to 255 is the pixel values, and the RGB triplets value will be different. So the thing is, I will tell you another example. Say this is a list, 1, 2, 3, and this is another list. This is 2, 3, 4. Now I'm performing a addition operation between these two lists. Say C equals A plus B. So what happens? So the instruction is addition, right? So this is a single instruction, and we have multiple datas. So we need to perform addition between these two, like 1 and 2, 2 and 3, and 4 and 3. So the output will be like 3, 5, and 7, right? But in the SIMD, it won't treat every addition as a single instruction. It will be treating all in a different ALUs. In GPU, it will be distributed, like each of this work will be assigned to different ALUs, and it will perform simultaneously. Then it will accumulate the results together to give this result. So this is how the SIMD will work. And hope you got some clear idea about single instruction and multiple data. Why? Because modern GPUs are been following this, and there are multiple things are there. We have seen only SIMD, but there are. I need to tell about Flynn's. I need to tell about Flynn's taxonomy. So he classified how the instruction and data will be followed in different cases. So one is SISD, single instruction, single data. Another one is SIMD. Then multiple instruction, single data, multiple instruction, multiple data. So this is the classifications of Flynn's taxonomy. Now you got a clear idea, right? If you want to learn more about these things, I will be covering some of the OCR models. Like these are some open source OCR, and this is vision language based OCR. And these two, these uh, Vision API and Amazon Test Track are the cloud services which is being provided by GCP and AWS. Now, both of them are nothing but an endpoint where you can send your documents to Vision API, and it will return a text blob of that extracted text. And both of these services are highly expensive. Like when you need to process a large amount of documents or corpus, it can be really expensive. If you need for business or enterprise level application, you can go with this. For learning purpose and experimentation, you can go with these models, and these are way better than this. And you have high customization in these models compared to this Vision API and Amazon Text Stack. When we see the this open source OCR, the main motive of this is only to extract the text from the given document. So that's the main objective of this. It doesn't have intelligence. It only can detect the layout. It can able to extract the characters, but it doesn't have document understanding. So you need to keep in mind. And this have a variety of algorithms or deep learning techniques to do this extraction. Whereas it is highly suitable for structured documents. Say if you have an invoice, if you have a document which is highly structured and the layout is not going to change, then these OCR perform exceptionally well. Then when you can use this vision language model, you can use the vision language models when it comes to document understanding. Document understanding. And if you need to have document reasoning, also it can work. Document, you have document reasoning. You can use vision language models. Why? Because this vision language model has something called VIT and vision encoders. Vision encoders. VIT is nothing but vision transformers. So you can search about it later. These vision encoders are responsible of capturing the features of the uploaded image and which has been sent to this language model. Again, it is a language model. We just have the vision encoders. That's all. Again, it's a normal language model which is capable of generating human-like text. I personally used these three. I personally used these three VLMs. Mistral OCR, which is around I think 7 billion parameters, which has a vision capability. It comes around 5 to 6 GB. You can just download the open weights and you can run in your own hardware itself. And these are some vision language models I really need to speak about. Then we can proceed to the next phase. Okay, now we have ensured that you have installed both the CUDA driver as well as the CUDA compiler driver properly, and you need to get these both outputs. Like if you want to work with the CUDA program. Now, if you want to install PyTorch, actually PyTorch has both the CPU as well as GPU version, but I recommend using the GPU version, but because you can actually see the difference in execution of the instructions. If you want just to install the CPU version, you can simply use this command pip install torch and torch vision. If you want the GPU version, you need to check with the version. This is 13 and 12.6. In our terminal, you can see we have the CUDA version 13. So I will be installing 13 or 13.2. Actually, installing 13 is the safe version. Why? Because sometimes the latest version may be not a stable version. So just I will install this. Before installing anything, you must need create a safe virtual environment or else it will be added to your global packages. So ensure that you work inside a isolated environment. And also you can also install 12.6. Why? Because CUDA drivers are backward compatible. So you can either install this or this. That's based on your requirement. So either you can install this, but that's a catch. If you want to use this PyTorch, you'll be installing this in a virtual environment, right? For each and every project, you will be installing this PyTorch. So instead of that, you can either use another thing called the NVIDIA NGC. You can just use this NVIDIA PyTorch container. So this is a GPU accelerated container. So you can just open this. So this NVIDIA PyTorch container is a GPU accelerated container. You just open your Docker and ensure you have sufficient memory. Why? Because it will come around 28 to 33 gigabytes. So ensure you have enough disk space. Like once you install this container, you don't need to install the PyTorch using this command for each and every project. You just open your Docker and just execute these instructions. You will be having your PyTorch for every project. Whenever you need PyTorch, just use the container. Simple. So this is one thing I need to tell. Currently, I have 512 GB of space, so I don't want to use this. I will anyways clear my environment once I completed my project. But this is a trick I want to say to you to use the GPU efficiently and the memory efficiently. Then we'll be seeing the TextLens. Now we have seen all these things, right? You need to check proper hardware, ensure you have NVIDIA toolkit. These two things you must need to do manually. The framework which I created will not handle this one. But once you install this, my framework is capable of checking your hardware, whether you have a GPU or not. So let me show you. So first of all, you need to install the, I will show you. So first of all, you need to install my package using pip install TextLens. Like once it is published in the official Python package, it will be showing like this. Currently, I'm in a testing environment, so this installation command may vary, right? So I've already installed you. Let me just show you the pip list. So pip list command will basically gives you all the packages that has been installed inside this virtual environment. So see, these are the installed packages in this environment. As you can see, mm, yeah. So you can see the text lens has been installed properly. Um, the text lens is being installed properly. Now, once you install the text lens, I have created some CLI commands like text lens models. So once you enter this command, text lens will open its model registry or catalog. It will show the supported, models. You can see the we have GLM OCR, we have light on OCR, we have Honian OCR and small VLM. And you can also see the parameter, the size of the models. And this is the bare minimum hardware requirement to run these models. For GLM OCR, you at least need a 6 GB of VRAM. For Lighton OCR, you at least need a 8 GB of VRAM to run smoothly. And for Union OCR, you need around 8 GB VRAM. This equivalent to 1 billion, it is around like 980 or 90 something, not exactly 1 billion. And small VLM is the most smallest VLM, hence it is very much accurate. This accuracy of this model really impressed me. This only require a hardware of 2 GB VRAM minimum. And this is use cases. This is for high accuracy task. These all three are for high accuracy, proper unstructured data extraction from the documents. So now you got idea about our TextLens models. We have a lot of thing like TextLens Doctor. So this command will basically analyze your entire hardware, right? Like I have shown you in the task manager, right? So it will basically fetch all the information from your operating system and it will basically display here. So it may take a few minutes to, capture all your information from your OS, which includes your GPU also. So the TextLens Doctor will detect whether you have GPU or not. And if you have GPU, it also recommend which PyTorch version to install. Exactly. So now you can see this TextLens Doctor CLI command uh, returned the system information as well as the hardware analysis. Now you can see this is the operating system. This is my PyTorch, which is I have downloaded the GPU version. I have a GPU of NVIDIA RTX 4050, 6 GB VRAM, i5 13th gen. I have a 8 physical and 12 logical cores, and I have a RAM of 15 GB and device is CUDA. If you don't have this CUDA, it will say GPU detected no, CUDA ready no, and it will tell you the CPU alternatives here instead of recommending this. So right now I have a GPU, so it is recommending these models. If I don't have a GPU, it will be redirecting and recommend this small VLM. This small VLM is capable of running in CPU. So I hope you like this feature which I integrated in my TextLens framework. Still, I will be continuing this more in the next video. So now we'll be seeing the actual code implementation of our TextLens framework. So each and every time when I used to integrate the OCR function in my application, it can be a web application or it can be a mobile application, whatever. Each time I need to write the code from the scratch for creating the OCR pipeline. But this TextLens framework will abstract most of that and we can simply write 3 lines of code to perform the OCR. And we have a lot of functions like batch process and serving the model in a REST endpoint, and we can easily switch between models. And once you download the model, it will be stored in a cache memory. So each and every time you don't need to install the model again and again. So that's the unique features of TextLens. So now we have written a simple code. So have from TextLens I've imported the OCR class and I've created a instance for that. Inside this, you need to pass a parameter, and that is model. And in this model, you need to pass only the model which has been available in the TextLens catalog. Like you see TextLens models, you only need to enter this model as an argument. Like you don't if you enter some other models it won't work. Why? Because I have not added it yet. In future surely we will expand this catalog, but for now we have only these 4 models supported in our catalog and not TextLens framework. So currently I'm using GLM OCR and I have enough amount of VRAM, I hope so. And we have a sample image. So this is an invoice image which I downloaded from the internet. Now we are going to execute this code. So currently I am in my project directory. My virtual environment is active. Now I'm going to run Python. The file name is trial.py. Trial.py. So what happens now is it may take time. Why? Because already my GPU is being loaded with some other task. So this code will execute. So what happens here, I will explain. So the model is already installed in my particular environment. So it will first load the installed model weights, then it will perform OCR, then it will display the result in the terminal itself. So let's check the accuracy of this OCR once the result is obtained. Yeah, we got the output right. Now let's check the accuracy of this. So we got this invoice, bill to lost the service, and we got the date, invoice, item. The table is being displayed like this, but it extracted everything as it is without any kind of mistakes. Yes, it's perfectly extracted the content. Yeah, this is how easy we can use our TextLens to do OCR on the images. And we have a lot of features like we have hardware and we have batch process. We have, I think so, we have batch process and we have server. So in this server we can serve our application at endpoint. I will showing all the codes for you. Right now we have examples folder, I think. Yes, here. So this is the thing we've seen. We have just created a basic instance for this OCR class and executed it. And we'll have a lot of parameters. And I will just show you one thing. Server, yes, this one. Okay. Now, once you have, created a model, like you are satisfied and you want it to go into production, you want to test it as an API. Like you want to send an image to an endpoint and the server should process it and return back the JSON. So instead of writing an entire fast API code from scratch, I created a function called serve. So basically, it will load the current model which you selected. Right now, we've selected the GLM OCR, right? So the GLM OCR will be loaded and it will be served in this endpoint, like the local host 8080. It will be served through this endpoint. And we also have the API documentation. You can refer to it. And this is for batch processing. And yeah, the batch process is nothing but this is again a class we need to import TextLens.batch import batch OCR. Like we have used the traditional Python queue. Like in future, we can implement in AWS if we scale this application. But for now, as a prototype, I simply used the normal Python queues for storing and organizing the incoming request. Then this the worker will pull out a pop a job from the queue and will perform the batch OCR. Currently, the batch OCR has these parameters. You need to give the model. You need to give number of workers that should work concurrently, and which obviously use your GPUs. Then you need to give an output format either as a JSON or TXT or a markdown file. Then you need to specify the output directory. Like once your batch OCR completed, it will map all the input to this output directory properly. And if any failure happen, you can also specify the retries you need to do. Then you need to specify the DPI. So this is a threshold we are setting. So the incoming document should at least have 200 DPI to ensure a better accurate extraction. Then the device can be specified. Defaultly, it will be selected as CPU. If you have GPU, it will be switched to GPU and enable dashboard. So it also give a dashboard facility for you. Like you can monitor all your batch processing task in a visual way using this dashboard. And this dashboard is we've been live in this particular port number, and this is a max tokens. Like if we are using with the vision language models, right? Obviously, it has a context window limit. So you need to mention the max tokens. And yeah, this is the documentation of this. And I'll be sharing all this code. This is the testing code for every feature we have in our application. You can just use it and give your reviews. And this is what the text length. It obviously abstract a lot of complexity of using a OCR in your hardware. Usually, it will take a lot of time and setting up the complex CUDA, everything. And you need to identify which CUDA driver you have, and you need to install the PyTorch GPU supported package based on your CUDA driver. So you don't need to search and don't need to worry about it. Our TextLens doctor will itself suggest you the suitable PyTorch GPU version in order to use the GPU accelerator library. And thank you so much.